Well, it's too bad you can't see faces in YouTube videos because right now in the class, everybody looks exhausted. They've had 4 days of rest and relaxation. Today's a rainy, dark Monday, November. Are we 7th today? November 7th? November 7th. And we have 9 questions for our warm up. Uh, the first four questions, actually all of them, the first 6 questions are a review from previous chapters, and the last 3 are from this chapter that we're currently working on. So our first question is actually taken directly from your test, and so many students had it wrong, I had to go over it again. It says negative 17/5 is equal to negative 3 over 2. So your strategy is either to convert them both to fractions or, conversely, both to decimals. The easiest way is to choose changing that fraction to a decimal. And of course, given the fact that you were allowed to have a calculator, the easiest way to change a fraction to a decimal is to take your numerator and divide it. Oh, something went south here. Let's try this again. Take your numerator, which is 17, and divide it by your denominator, which is 5, and it tells you 3.4. So therefore, it would be negative 3.4 is equal to negative 3.2, which of course is false. Alternatively, you could have said negative 17/5 is equal to negative 3, which is 15 and 2/5, which is equal to negative 3 and 4/10, which is equal to negative 3 and 4/10. But either way, you're telling me the answer is false because negative 3.4 does not equal 3.2. Question 2 says estimate using money. So we're going to round to the greatest place value of money, not 1 and 0. We're going to actually make this 50 cents. And we're going to divide it by, what's the closest money value that's closer to 0.0483? A nickel, right? 0.05. So when we convert this to money, I said I have 50 cents divided into piles of nickels. How many piles of nickels? Right? How many nickels are there in 50 cents? Anybody? 10. And therefore, your estimation is 10. If I took the calculator, which is now maximized, which is too big for me, so I'm going to make it smaller. If I took the calculator and said, what is, oh shoot, I can't even do that this way. Hang on, let's just pause. Maybe that's a little better. What is 0.486 divided by 0.0483 and press equals? It tells me it's 10.06. So using money, my estimation was pretty accurate, but our estimation is going to be approximately 10. Third question, or fourth question, or third, what are we on? Third question? Third question. Fraction question. 2/3 plus negative 3 over 2. Common denominator is 6. 4 and negative 9, because we're going to multiply this by 2 and multiply this by 2 and multiply this by 3 and multiply this by 3 to get equivalent fractions. Now, hopefully on your paper, you wrote this, and if you didn't, that's okay. You don't need to have it. But your final answer will be impacted if you wrote or didn't write that statement, because you probably made a mistake somewhere around the line. But the answer is negative 5/6. Our next question comes from the previous chapter on square roots of rational numbers. And it says, since 16/25 is a rational number, it's a fraction or a terminating decimal. What is that? What's the square root? So what fraction multiplied by itself is 16/25 is really the question. Numerator is 4, denominator is 5. Therefore, the square root is 4/5 or 0.8 if you want to think of it as a decimal. Next question gives us a chart. It says write it as a fraction, decimal, and percent, so negative 2/5. Since negative 2/5 is equal to negative 4/10, then negative 4/10 is what it is as a decimal. You can also divide the numerator and denominator. And since negative 4/10 is equal to negative 40 hundredths as a percentage, it's negative 40 percent. As a decimal, 0.08 is 8 thousandths as a fraction, which is your answer. Or lowest terms, you could reduce it down to, what would that be, 4 500ths or 2 250ths if you're thinking in lowest terms. But it's also equal to 0.8 over 100. Now, that's not a good fraction. We don't like to show our fractions with decimals in the numerator, but it is important for the reason that because it's a fraction with a 100 denominator, The numerator is actually expressing the percentage. So it's 0.8%. And 1.5% is 1.5 out of 100, or more appropriately, with no decimal, 15 over 1,000. And 15 thousandths is 0 tenths and 15 thousandths as a decimal. Our next question is from Pythagoras. It gives us sides of 4 and 7, so we can solve it with squares, which is probably the easiest way to do it. The area of this square is 16. The area of this square is 49. The sum of those two squares is 59/65. Therefore, x is equal to, not approximately, to the square root of 65, which is approximately equal to, since the square root of 64 is 8, the square root of 65 is probably like 8.1 or 8.05 or 8 point something like that. But we're going to use, without a calculator, 8.1. We're not going to grab a calculator because we're pretty smart people. Roughly that. True or false? How many said true? How many said false? How many did not answer it for fear of being wrong? Nobody. This says -2 squared, which means because the brackets are around the -2, it's used in repeated multiplication. So -2 times -2 times -2 times -2 is positive 16. And over here, this actually says the opposite of 2 to the exponent of 4. And since 2 to the exponent of 4 is 16, then the opposite of 16 is going to be -16. Because the brackets are not around the -2, it is not the base, and it is interpreted as the opposite of 2 to the exponent of 4. So it is false. They are not equal to each other. Next question gives us exponential forms. It's actually just kind of a simple BEDMAS question. Just addition and subtraction, so we're going to solve it in the order they appear from left to right. 3 cubed is 3 times 3 times 3, which is 27. 4 to the fourth is 4 times 4 times 4 times 4, which right off the top of my head is 16 times 16, which I think is 256. And then take away 2 to the 10, 2 to the 10, 2 to the exponent of 10 is 1024. So take away 1024. This is going to be 276, 283. Take away 1024. Fortunately for us, we can use a calculator because that's one of those questions I don't want to think about Monday morning. And we get -741. And is this our last question? Yes, right? So this is actually taken from the chapter you're currently working on. And inside the brackets, we're asked to do that first. Now, based on the laws that you were studying last class, if you have bases that you're multiplying or dividing, the rule is if you are multiplying powers that have the same base, the rule is keep the base and add your exponents to get 2 to the 7. Oh, I shouldn't have done this one. I just realized now I made a mistake. When you're dividing, what are you supposed to do? Hayden, what are you supposed to do when you're dividing powers with the same base? You're supposed to keep your base and subtract your exponents. So therefore, this whole power here is going to work out to be 2 as a base. And unfortunately, it ended up being something I'm not usually, we don't talk about negative exponents, but we can have them. It exists. So when I simplify the brackets, I'm going to get 2 to the exponent of -3. And what happens when you have a power to an exponent? What's the law say? It says, you can think of it like this. So 2 to the -3 times 2 to the -3 times 2 to the -3. Or a more appropriate way is keep the power and multiply your exponents. So your final answer is going to be 2 to the -9 as a power.